Welcome to the 16th lecture in the course of Industrial Engineering and Operations Research. We have discussed many things. In the last few lectures, we discussed about quality management and quality engineering. Now today, the talk will be on forecasting. You know that everyone is very eager to know the future. In the early days, some businessmen, when they want to go for business, they would consult astrologers. Even the farmers will ask that auspicious time from the village astrologer for sowing the seeds in the ground. So everybody wants to take a cautious decision. So we are also discussing this topic, but not on the basis of astrology, but on the basis of some mathematics, particularly seeing the trend. Can we predict that what will be the demand in future? That is the forecasting. So we take the help of the previous data and we predict for future. We may take other considerations also. So it's very mathematical in nature. Okay, so what is forecasting? Forecasting refers to the practice of predicting what will happen in the future by taking into consideration events in the past and present. Then forecasting is a decision making tool that helps businesses cope with the impact of the future's uncertainty by examining historical data and trends. So time history analysis is very much related with the forecasting. We have past data, based on that we are making the inferences for future. So in supply chain, forecasting refers to the process of predicting demand, supply or pricing for a product or a range of products in a particular industry. So now how can you forecast? How much you can tell that somebody is interested what will happen tomorrow, somebody wants to know what will happen after 1 year, somebody wants to know what will happen after 10 years, like that. So we have forecasting time horizons and they can be classified in various ways. One is the short range forecast. This forecast is usually used for 3 months or less. It can be up to 1 year. So it is used for planning purchases, hiring, job assignment, production levels and things like that. So you can, what I have to purchase next month, how many people I have to hire within 3 months, like that. Then medium range forecast this is for 3 months to 3 years. And medium range forecasts are used for sales and production planning, budgeting and analysis of different operating plans. Then long range forecast is 3 years or more in time span, used for new products, capital expenditure, facility expansion, relocation and research and development. Like I may decide that I have to open a factory for totally electric vehicle and I have to phase out a conventional IC engine operated vehicles. So this type of decision we generally take at the top level and these are long term planning that we do that. These numbers like 3 years or more in time span are not very rigid. That means sometimes it may be that 2.5 years, more than 2.5 year time also can be called long range forecast. So this is just some distinction that one is short range forecast, other is medium range forecast and third is long range forecast. Now medium and long range forecasts are more comprehensive in nature. They see all the aspects and they then support and guide management decisions in planning products, processes and plants. Like we can plan in medium and long range forecast that what type of product company will make, what type of processes will be employed and where we have to set up a plant, like that. But in short term forecast, which will be mostly the topic of today's lecture, We anticipate immediate future needs and impact. Short-term forecasts use existing data in mathematical formulas. It is mostly quantitative in nature and use. It is relatively more accurate than medium or long range forecast. It is obvious that it should be more accurate. Long range and medium range forecasts may quite often fail. Short-term forecasts are to be updated regularly to maintain their effectiveness. So, what are the type of forecasting? We do economic forecasts. It addresses the business cycle. They predict inflation rates, like what will be the value of dollar in comparison to rupee in coming 2 months, like that. It can be money supplies and other indicators. So, it is connected with economic. Then there are technological forecasts. It monitors the rates of technological progress. This keeps organizations aware of trends and can result in exciting new product. What will be the technology? What is the trend? Whether electric vehicles will be more in demand compared to traditional IC engine type of vehicles. So, new products may require new facilities and equipment. It must be planned for in the appropriate time frame. Demand forecasts deal with the company's products and estimates consumer demand. So, it is demand forecast, mostly marketing people are very much interested in that. It is also referred to as sales forecast, have multiple purpose like driving scheduling, that how to make scheduling, how accordingly we should schedule the things, production and capacity. So, scheduling, production and capacity, everything. Then steps in forecasting system. So, determine first what the forecast is for, what you want to forecast. You want to forecast rainfall, you want to forecast cyclone coming maybe next month, you want to forecast market trend, you want to forecast demand of a product. Then select the items to be forecasted, which items you want to forecast, like maybe sale of scooter. Okay, so you have to focus on scooter sale. Select the time horizon. Is it short, medium or long term? Select the forecast model type. Is it quantitative or it is qualitative? Then gather data to be input into the model. Then make the forecast, verify and implement the results. So, as we have said that there are two approaches, one is qualitative approach, other is quantitative analysis. So, qualitative forecasts are a subjective approach. It incorporates factors such as decision makers' intuition, emotions, personal experiences and value system in reaching a forecast. Some firms use one approach and some use the other. Quantitative forecasts use different mathematical models. These rely on historical data and their associative variables to forecast demand. So, we will discuss more about quantitative forecast only, but let us just have a look at various qualitative forecasting techniques also, because they are also important. So, there can be various ways or combination of these ways. So, one way is that jury of executive opinion. It is based on the inputs and decisions of high level experts or management. They may sit together or their decisions may be collected and then somebody can take the decision. So, these people are highly experienced, their inputs will be very important. So, Delphi method is another method. In that, decision makers, staff and respondents all meet to develop the forecast. It is variety of people are there. Every shareholder in the process provides input. Maybe that manager is giving some input, then supervisor is giving another input, maybe some representative from the customer side also are giving input. Then we reach a group consensus on a complex issue by gathering opinions from a panel of experts in a series of rounds. So, this is very important that we obtain the opinion in a series of rounds. We have to so it is sometimes this type of method is done, that like we make a group of experts. They may be from worker community, they may be from manager community, every place, and they will be marketing side, and all people give opinion on some complex issue. Then the opinion of one group is showed to other group also that this is the opinion they have given, and they are given a chance that if you want to modify your opinion, it is fine. So like that we go on doing that type of thing. It is not blind that I have given some opinion and that is fixed. Maybe I give some opinion, other person give some other opinion, and then I was told his opinion, then I modified my own opinion. Yes, it may be like this, or slightly I changed my estimate like that. So that is what it is important thing is that it is done in a series of rounds, okay, not in one round. Then sales force composite. Each salesperson provides an individual estimate which is reviewed for realism by management and then combined for a big picture view. Then consumer market survey. This is surveying the prospective customer base to determine demand for existing products and can also be used for new products. So we can have market survey. We all know that lot of unsolicited surveys keep coming to us, okay, request for survey, and we have to, sometimes we ignore that, but sometimes we give the feedback, and there are many other ways to do market survey. So that method is also there. Then in the quantitative analysis, there are extrapolative or time series method which uses past history or demand in making a forecast for the future. The pattern in historical data is identified and extrapolation is done. Now for short time margins, this method works well. If we know the data of past 5 months, maybe we can predict for 6 months. Another method is causal or explanatory method. So this is basically causal or explanatory method. That means it is based on that cause. So we say better to say it explanatory method only. So this is explanatory method which is based on the explanation. It assumes that the demand for an item depends on one or more independent factors, or we can say cause. So this is cause. E.g. price advertising. Say something, you can say, okay, I am doing advertising, so my demand will go to increase. I am reducing the price, so demand may increase. So that type of relation is there, and by mathematical formula you can find out that if I do this much pricing, what should be the demand. Means you can forecast or you can estimate. A relationship between different variables is established. That means basically cause and effect type of thing. So you can say that is why it is causal method, cause effect, okay. So that is why it is called this method. Now but we will first discuss more about extrapolative or time series method. Extrapolative methods identify patterns in past data. These patterns depend on 4 components of demand: horizontal demand, trend demand, seasonal and cyclical. Horizontal component of demand exists when the demand fluctuates about an average demand, that is more or less demand is horizontal. Suppose this is time and on y axis I make a demand, this is demand, okay, demand. Then you have something like, suppose horizontal, that means demand is almost constant, but random fluctuations may change it a bit like that, okay, that type of thing. Trend means there is a trend in the demand, that suppose demand is increasing with time, so there is a trend. Demand is decreasing with time, there is a trend. Seasonal, that means it depends on the season. Rainy season something is demand is different. And cyclical means, okay, it keeps fluctuating, sometimes it is more, then it is less, like that. So horizontal components of demand exist when the demand fluctuates about an average demand. The trend component of demand refers to a sustained increase or decrease in demand from one period to the next. And the seasonal component of demand pertains to the influence of seasonal factors that impact demand positively or negatively, like sale of umbrella will be more in the rainy season. So, this is a seasonal demand. Cyclical component of demand is similar to the seasonal component, except that seasonality occurs at regular intervals and is of constant length. That means it is not only dependent on the season, but basically dependent on the time, that every 3 months this happens like that. So, what are the methods? So, simplest method of forecasting is moving average method. It is the simplest extrapolative method. 2 steps are required to make a forecast for the next period from past data. Select the number of periods for which moving averages will be computed. This number n is called an order of moving average. Then take the average demand for the most recent n periods. This average demand then becomes the forecast for the next period. It is so simple. I explain this with the help of example. The demand data for a product in the months of January, February, March, April and May, these 5 months, it is 100, 90, 120, 80 and 110 units respectively. Forecast the demand for the month of June, that means for next month. Now, you choose some order, say n is equal to 4. Suppose we have chosen 4. So, we just take the past 4 months average. Other values can also be chosen. You can take n is equal to 3, but we have taken 4. Large n values will have a greater smoothing effect on random fluctuations in demand. So, average demand for the most recent 4 periods, n is equal to 4 will be estimated. Moving average will be demand of for February, March, April, May divided by 4. So, this will be 90 plus 120 plus 80 plus 110 by 4. This is equal to 100 units. So, forecast for June will be 100 units. Okay. So, this will give a type of, we are converging to something like average type of things. There may be overestimation or underestimation, but hopefully it will, error will not be that much. Okay. That is what our assumption, that is why we are following this method. Now, suppose the actual demand for June turns out to be 90 units, then forecast for July will be computed by taking the average demand for March, April, May and June. So, forecast for July will be further updated. Now, you have to take past 4 months. So, it starts from March, 120 plus 80 plus 110 plus 90 by 4, that means 100 units. So, earlier also we take 100 units. Now, this is also coming 100 units, okay, because we had taken that way. So, after n is selected, the new moving average for each future dip period is computed by taking the average demand for the most recent n periods. The disadvantage of this method is that it requires the storage of demand data for n periods for each time. Also, this method is not applicable if the demand data reflect trends or seasonal components. Suppose demand is increasing or it is dependent on season, then it is not coming here. So, if there is an upward trend, then the forecast made by this method will underestimate the actual demand. So, we have another method that is called exponential smoothing method. In this method, the weight assigned to a previous period's demand decreases exponentially as that data gets older. So, recent demand data receives a higher weight than other older demand data. So, it is also average, but we give more weightage to latest data. Exponential smoothing methods are particularly attractive for production and operations applications that involve forecasting for a large number of items. Forecasting horizon is relatively short. It may be daily, weekly or monthly demands need to be forecasted. This method is used when there is little outside information available about cause and effect relationship between the demand for an item and independent factors that influence it. So, in the basic exponential smoothing model, the simplest exponential smoothing model is applicable when there is no trend or seasonality component in the data. Only the horizontal component of demand is present. Because of randomness, the demand fluctuates around an average demand which we call as a base. If the base is constant from period to period, then all fluctuations in demand must be due to randomness. In reality, fluctuations in demand are caused by both changes in the base and random noise. So, the key objective in exponential smoothing models is to estimate the base and use that estimate for forecasting future demand. So, let us understand it mathematically. In the basic exponential smoothing model, the base for the current period, that is ST, is estimated as current period base. That means where I am interested to forecast, there we make a base. So, that means it is estimated by this one, new base is equal to previous base plus alpha time actual current demand minus previous base. Okay. So, you multiply factor alpha, which is between 0 to 1. If I put alpha is equal to 0, then new base will be previous base only. We will not give any weightage to our actual observation, but if alpha is equal to 1, then new base will be actual demand only. So, like that it goes on. So, both are extreme cases, we go somewhere in between. So, in mathematical symbol, we can say ST, that base, is equal to ST minus 1 plus alpha dt minus ST minus 1. So, ST is equal to base for the current period, ST minus 1 is previous base, dt is actual current demand, and alpha is called smoothing constant that lies between 0 and 1. dt minus ST minus 1 is the observed error for period t. So, this whole thing can be called error. So, alpha times error, that means you are giving some weightage to error actually in this method. So, equation 1 can also be expressed as ST is equal to alpha dt plus 1 minus alpha ST minus 1. That means smoothing constant times actual demand in period t, and then what happens that you do that, you base also you modified. So, you will get a new base from that. So, properties of the exponential smoothing model, this method is simple and requires that minimal information be stored for each item. Unlike the moving average method, for which all past in observations must be stored, the exponential smoothing model requires only two pieces of data, the most recent demand and the previous base. Only we need to store this dt and ST minus 1. The procedure can be easily automated and the data entry in each period is only the new demand information. So, let us take one example. A mobile phone manufacturer forecasted the sales of mobile phones in February to be 140 units. However, the actual sale was 150 units. By exponential smoothing method with a smoothing constant of alpha is equal to 2.2, the sales forecast for the month of March is how much unit. So, up to February you have got the data, you have to predict for this one. But you had estimated for February, forecast for February was 140 unit. So, this I am calling ST minus 1. In the time period, actual demand for February was dt, that is 150 unit, alpha is equal to 0.2. So, to find out ST, that means forecast for the month of March, ST is equal to alpha dt plus 1 minus alpha ST minus 1, that means 0.2 into 150, because 150 is the actual sale, plus 0.8 into 140. So, it comes out to be 142 unit. So, we will say that it is 142 unit. So, if you take small values of alpha, it will have a stronger smoothing effect than large values. Okay, that means demand will be more or less unfluctuating, because I took alpha is equal to 0.2 only. So, my earlier forecast was 140, now it is 142 only, although the sale was 150. So, conversely, large values of alpha will reflect real changes in actual demand as well as random variations more quickly. If fluctuations in demand are primarily due to randomness, a small alpha should be chosen. If fluctuation in demand are due to a shifting base, that means some trend type of thing is there, then a higher alpha should be chosen. So, now properties of exponential smoothing model, little bit more I will tell. St is equal to alpha dt plus 1 minus alpha St minus 1. Never forget this formula. In extreme cases, the values are alpha is equal to 0 and alpha is equal to 1. If alpha is equal to 0, then St is equal to St minus 1. In this case, the new base is the same as the previous base. All fluctuations in demand are attributed to randomness. So, therefore, we do not change the base, we say that this is the average one. If alpha is equal to 1, then St is equal to dt. In this case, new base is the new demand and the previous base is totally ignored. It is assumed that the new demand has no randomness and the base has in fact shifted. Okay. So, we will just do that. A small alpha has a greater smoothing effect on demand. It is usually recommended that an alpha between 0.01 and 0.3 be chosen. It is also possible to conduct an empirical test in which alpha is varied and forecast errors are computed for several alternative values of alpha. The value of alpha that produces minimum forecast error is then chosen. It is important to recognize that at least 1 year of historical data are required before confidence can be placed in the resulting forecasts. So, now I will discuss what are various type of forecasting error. Forecast error is defined as ET is equal to actual demand for period T minus forecast for period T. So, we can simply add all the errors and divide by number of observations n and we can find out average error. So, this is the average error should be near 0 for a large sample, otherwise the model exhibits bias. If average error is this side or that side, that means it is a bias. Bias indicates a systematic tendency to forecast high or low values for demand. However, AE obscures variability because positive and negative errors cancel out. So, therefore, with this we can calculate another measure, that is mean absolute deviation, that is MAD. This is equal to 1 by n, T is equal to 1 to n period and absolute value sum. So, mean absolute deviation provides additional information that is useful in selecting a forecasting model and its parameters. MAD is simply the sum of all errors without regard to algebraic sign divided by the number of observations. Mean squared error, it will be 1 by n, sigma t is equal to 1 to n E t square. The mean squared error provides information similar to MAD, but it penalizes large errors. So, MSE is computed by summing the squared individual errors and dividing by the number of observations. So, we can have this one. Then mean absolute percentage error, that is ET divided by dt into 100, t is equal to 1 to n. The mean absolute percentage error MAPE is a relative measure that is computed by dividing the forecast period for period T by the actual demand for period T and thereby computing the percentage error in period T. So, now suppose I give the example that this data is there, period for 5 periods we know the demand and corresponding forecast. Demand is 20, forecast is 22, demand is 40, forecast is 38, like that. So, forecast error for any period will be dt minus St minus 1 demand and corresponding forecast. Okay. So, percentage error in period T will be forecast error in period T, demand in period T into 100. Let us see that this one, suppose you have 20 but forecast is 20, so error is minus 2. This is 40 minus 37, 3, 10 minus 13 minus 10 is 7, so 40 minus 37, this is 10 and this will be 20 minus 16 is this one. Okay. And this is about this becomes 30 minus 32 and this is actually this is 20. It seems that here demand is, this demand is also taken as 20, that is why 20 minus 13 is equal to 7. So, there is a that error. Okay. Here maybe this should be 20 as per this calculation. So, this is 7. So, error square is 4, 9, 49, 16. Percentage error is also calculated, minus 2 divided by actual demand 20. So, minus 10 and you get percentage. Now, average error will be simply summing this together, minus 2 plus 3 plus 7 plus 4 minus 2 by 5 is equal to 2. Mean absolute deviation will be simply add the absolute values divided by 5 data. Mean squared error, that means square the errors, divide by 5, you get 16.4. Mean absolute percentage error, that means percentage errors in the absolute way have been added, divided by 5. So, this is how that it goes, and we can classify exponential smoothing models in other ways also. We can put more complicacy. We can have linear or additive trend model, ratio seasonality model, additive trend and ratio seasonality model, initialization, adaptive methods. So, let us tell about linear or additive trend model. The apparent linear trend in exponentially smoothed average is the difference between the successive values st minus 1 gives idea about linear trend. Sometimes a negative trend is recorded when in fact the general trend is positive. To minimize these irregular effects, we stabilize the raw trend measures in the same way we stabilized actual demands by applying exponential smoothing. So, st minus 1 series can be smoothed with the smoothing constant beta. This smoothing constant need not have the same value as the alpha used in smoothing constant dt. So, for example, mathematical expression of basic exponential smoothing model can be modified by simply adding the old smoothed trend to the previous base as follows. That means st becomes alpha dt plus 1 minus alpha, but this is not only st minus 1, we have added some trend component, that is tt minus 1, and trend estimate can be calculated as tt is equal to beta st minus 1 plus 1 minus beta into tt minus 1. So, equations A and B yield smooth current values of demand and trend. Therefore, to forecast the upcoming period, we extrapolate by adding tt to the current smoothed average. That means, if forecast for the next period will be st plus tt and forecast for m period ahead will be ft comma m, that means for mth period st plus mtt. This concept is useful in some of the more complex models that combine estimates of average demand, trend and seasonal components. Just to give one example, a manufacturer wants to forecast demand for a piece of pollution control equipment. A review of past sales is done. The firm assumes the initial forecast average for month 1 was 11 units and the trend over that period was 2 units. So, smoothing constants are alpha is equal to 0.2, beta is equal to 0.4. Then forecast average for month 2 is how much? Alpha dt plus 1 minus alpha st minus 1 plus tt minus 1. So, this is 0.2 into 13 because actual sale demand was 13 here. So, 0.2 into 13 plus 1 minus 0.2, smoothing constant had been subtracted from 1, plus 11 because this was the forecast average, 11 plus 2, trend component was 2. So, we added 2. So, this became 13, and trend in period 2 will be tt will be beta st minus 1 plus 1 minus beta tt minus 1. So, this will be 0.4, beta is 0.4, and we put these values. So, trend came 2 only. So, therefore, forecast including trend came out to be st plus tt, that means 13 plus 2 units, that means 15 unit. Okay, so, that it has been done, and then we can do like that. So, this much only for today, and then on the forecasting we will continue in the subsequent lecture also. Thank you very much for your kind attention.